So dn was defined as per the definition as what? How do you get dn from x of t?
X of t summation.
Okay. x of t summation. لا.
Integration.
x of t هي اللي كانت summation. يعني we know that x of t is equal to the summation from n equals minus infinity to infinity dn e to the j n omega naught t, right? This is how you get x of t from dn. Now the question, I need dn. You have x of t and the question asks you to find the dn. What was the definition of dn?
Integration.
أيوة.
Integration.
لا, integration over one period. 1 over the period. And then what do you have inside? X of t e to the minus j n omega naught t, and you integrate with respect to time. تمام? Okay. Now, generally speaking, to get dn from x of t, you need to apply this formula. However, here things are much easier, because if you look at how x of t looks like, it's a bunch of cosine and sine functions added together. And we know that cosine and sine functions can be represented as complex exponentials already, right? So what would this look like? X of t, so if I move from this, I can write x of t as 1 plus the sine omega naught t becomes what? 1 over 2 e to the j omega naught t minus e to the minus j omega naught t, right? So if you take e to the j omega naught t and you subtract from that e to the minus j omega naught t and you take half of that, this is exactly the same as sine omega naught t. You know this or you don't know this? Now if you don't know this, how would you figure it out from what we learned before? What we learned before was that e to the j omega naught t is equal to cosine omega naught 2 t plus j sine omega naught t, right? And what if I write e to the minus j? Okay, so cosine minus omega naught t. Cosine minus omega naught t is the same as cosine omega naught t, right? So cosine omega naught t, and then becomes minus, because sine minus omega naught t is minus sine, okay? So it becomes minus j sine omega naught t. Now if you add those two formulas together, e to the j plus e to the minus j, the sine part disappears and you stay only with double the cosine. So the cosine becomes this plus this divided by 2. And if you subtract this from this, right, what you end up with is the cosine part disappearing, right? And you have, we missed something in that formula. And you have the j multiplied by 2 sine, right? Then this is equal to the subtraction of those two, right? Then the sine becomes the subtraction of those two, not just divided by 2, divided by 2j. Okay? So this is 1 over 2j. Okay?
Doctor,
نعم.
ليه subtraction مش addition؟
عشان عايز keep الساين.
الساين تروح كمان
اه
تروح مع بعض.
انا مش عايز الساين تروح، انا عايز الساين تفضل عشان اطلع الساين as a function من الاكسبوننشال، فبطرحهم من بعض عشان احتفظ بالساين وكنسل الكوساين. اوكي اوكي and what's the next one? 2, yes, multiplied by 1 over 2 the e to the j omega naught t plus e to the minus j omega naught t. And then the next, this cosine.
Doctor,
Now,
do we need to do 2 times 1 over 2, or we can just write it?
or you can just cancel them and just write this. Up to you. Yeah. I'm just showing what I'm doing step by step. Okay. You don't need to do this, يعني, because I'm explaining an example, so I'm trying to show every single detail. And then you have the cosine. The last cosine is 1 over 2 again, and it's e to the j. Now 2 omega naught t, right, plus pi over 4. all of this is multiplied by j, because all of this is the argument of the angle of the cosine, right? And this is added to e to the minus j 2 omega naught t plus pi over 4 as well. And then you close this. That's, now, if you want this to look similar to this, you have to gather together all the terms that have omega naught, all the terms that have minus omega naught, all the terms that have 2 omega naught, minus 2 omega naught. If I have 3 omega naught, minus 3 omega naught, 4, minus 4, and so on, so that this would look like this. And then immediately by comparison of coefficients, I can find the d0, d1, d2, d minus 1, d minus 2, and so on, right? So I just want this to look in this form, right? Because they are the x of t, so if I can make this look like this, I can just do comparison of coefficients, no need to do integration or anything, okay? So the next step is gather now. So this is x of t is equal to 1, that stays as is. And then I have what? E to the j omega naught t multiplied by 1 over 2j, that's one element. And it's also multiplied by 1 here, right? So 1 plus 1 over 2j, okay? And then I have e to the minus j omega naught t multiplied, in this case, minus 1 over 2j, minus 1 over 2j, and in this case, it's another one, plus 1. Okay. And then the next is e to the j 2 omega naught t, okay? And in this case, the coefficient is what? Half e to the j pi over 4, right? Don't forget that you have here this, right? Okay. And the last is e to the minus j 2 omega naught t, right? Multiplied by same coefficient, half e to the j pi over 4. Yeah, okay? So that's another coefficient and another coefficient. So now I can say what? By comparison, so by comparison of coefficients. Which coefficients? The coefficients of the formula and the coefficients that I got here, right? D0 is equal to, this is D0, whatever is multiplied by no exponential at all. So this is D0, so D0 is equal to 1. D1 is equal to whatever is multiplied by e to the j omega naught t, right? And that is equal to 1 plus 1 over 2j. Okay. D minus 1 is equal to whatever is multiplied by e to the minus j omega naught t, right? And that's 1 minus 1 over 2j. Okay. D2 is equal to whatever is multiplied by e to the j 2 omega naught t, because n here is equal to 2, right? And that's equal to half e to the j pi over 4. And then d minus 2 is equal to whatever is multiplied by e to the minus j2 omega naught t, and that's also the same thing, half e to the j pi over 4, right? Is it correct, or I missed the last one? To the minus. I think the last one, I think I made an error here. So for this one, it's a negative here, right? Because it's e to the minus j 2 omega naught t minus j pi over 4. Yeah, so that's minus as well. Okay? Okay? before I go to your questions. Okay. So what is the remaining part? dn for n greater than 2, right? And you would say the absolute of n, so positive n and negative n, right, is equal to 0. There are no more coefficients. Only d0, d1, d minus 1, d2, d minus 2, and the remaining coefficients are equal to 0, right? Because by comparison, this is the case. Now, several people have questions. Who had a question?
Shouldn't the last parameter 1/2 e to the power j shouldn't be 1/2j?
No. The cosine does not produce a j.
This is last one was the sine.
No, last one was a cosine. Cosine is double, right? So the cosine does not have a j. The sine is the one that has the j. Okay. Any other questions? Someone else had a question. Look back the question. Yes.
يعني كل واحدة لازم يطلع الماينس بتاعها. دي ان.
In this case, yes, but not necessarily in all the cases. واحنا قلنا قبل كده if x of t is a real function, is x of t as a time domain function is a real function, which is the case. هي عبارة عن شوية cosines added together, right? Cosine plus sine plus cosine. So that's a real function. In that case, you will always have the positive and the negative conjugate of each other. تمام? In the case that x of t is not a real function, يعني لو كانت x of t في حد ذاتها complex as a value, as a function of time, then you might have one side and not the other, or you have both sides but they are not conjugate of each other. Okay? Any other questions? So this is a simple form, right? This is one way that you can get the dn without really having to solve for integration or anything. And where will this happen, or which cases are these? The cases where your x of t is given by a few cosines or a few sines or even a few complex exponentials added together, right? So in that case, it's written for you in a form that's ready for analysis, just by comparison of coefficients, okay? You don't really need to do more than that. Now we will go to an example where life is not as nice as this case. If we have no questions here, we'll go for another example. No questions? طيب. Again, يا شباب, يعني you are dealing with two things. X of t is equal to summation from n equals minus infinity to infinity dn e to the j n omega naught t, right? And the other one is dn is equal to 1 over the period, integration over 1 period, right? X of t e to the minus j n omega naught t dt. Just simply, this is the frequency domain representation from the time domain representation, and this is the time domain representation from the frequency domain representation. In all problems of the Fourier series, you are dealing with those two. The only extra thing that you might encounter is I don't tell you explicitly what's omega naught. So I give you a function, and I don't tell you what's the period of that function and what's the fundamental frequency by looking at that function, which is periodic, because we are always dealing with periodic functions here. You just need initially to figure out what's your fundamental frequency. Because without figuring that, solving this is not going to be doable, right? Because you need the period here to integrate over 1 period. You need the omega naught anyways in the formula, so that the formula is complete for you, okay? So the first thing is just figuring out what's your, sometimes I will leave it as a general omega naught, right? But in most of the cases, you will have a given function, and from that function you need to find what's your fundamental period and what's your fundamental frequency, and then you solve for the rest. Yes.
طب سؤال دي 1 والدي نيجاتيف 1 مش ناقصين كده؟ لان هو كانت الانتجريشن اي باور نيجاتيف جي ان، فلو الان ب 1 تاخد الكوفيشنت بتاع نيجاتيف 1؟
لا ليه؟ مش فاهم.
المعادله الدي ان مش المفروض ان هي انتجريشن
لا المعادله دي okay. In this equation we have a negative here, but it has nothing to do with that d1 is the coefficient of e to the j. This is what tells you which d belongs to which one. النيجاتيف اللي موجود هنا ده as part of the calculation formula, and you remember where it came from, because when you do correlation between two functions, you have to take the conjugate of the second one. So this has nothing to do. It doesn't mean that when I take 1 here, which is equivalent to 1 here, it means it's the coefficient of e to the minus n omega naught. No, it's the coefficient of this. But to calculate it, you need to use this. تمام? So don't mix those two things together. Okay. Any other questions? طيب. I think the next one is written here. Yeah. So the other one was also written in the slides, but it was given like with the full solution. I wanted us to go through the solutions step by step with each other, and then eventually you look at the full solution in your slides. Periodic square wave, x of t equals 1 when t is smaller than capital T1, when the magnitude, sorry, the absolute value of t is smaller than T1, and it's equal to 0 when the magnitude of t, the time, is greater than or equal to T1 and less than t over 2. So we are dealing here with, and then it's a periodic signal. So this same pattern repeats. It doesn't say here, but it says the periodic square wave. So this means that you take that x of t and then you repeat it, right? It's not shown in the formulation itself, but keep it in mind. So here we are dealing with a signal that looks like this, right? If we try to plot this only x of t that we have here without the periodicity repetition, right? We plot something like this. So right, and then 0 up to a certain point here, and 0 up to a certain point here. And the distance between those 2 points is that capital T, and the distance here is what we call T1. Is this correct? The distance اللي فوق, I think. Yes. Now the distance flow is 2T1, right? Because from minus T1 up to capital T, so 2T1. So it has a width equal to 2T1, the high value or the 1 value, and then the rest is 0 up to capital T minus 2, capital T over 2 and minus capital T over 2 from the other side. So it has a full width of capital T. And then the same thing repeats over and over again. So this happens again here. You have this, and it keeps on happening from both sides, okay? Positive and negative side. So it is periodic, and the period is capital T, right? The period is not T1, it's capital T, okay? And it only has a non-zero value over the duration of 2T1, that duration. Symmetric around the 0 point. Anyone has an objection on the plot of this signal that I plotted right now? Or it's okay with everyone? مش عارف ازاي يتعمل. Okay, so if it's not clear, I'm gonna explain it again here. So simply we have the absolute of t is less than t1. What do we resolve an absolute value of t as to? It can be plus t or minus t less than t1. And this can be broken into two inequalities. Plus t is less than t1, minus t is less than t1. But this second inequality, if we want it to be on t, it becomes t greater than minus t1, because when you multiply both sides of the inequality with minus 1, we reverse the inequality sign, right, as you know. So now we have two inequalities that we have to combine. T1 is t is less than t1 and t is greater than minus t1. Combining those gives you t greater than minus t1 less than t1, which is basically what we have broken this into to do this plot. Okay. I hope this clarifies how it happens. The same also can be applied to the second part where we have an absolute again over the time.
T1 to T2. So
T over 2, not T2.
T2, yeah, T
Yes.
over 2. So how did you arrive to the conclusion that All of it.
It will go, because this is again an absolute, so this will happen from the right side and it will also happen from the left side, right? It's an absolute of t, not t only, right? So this happens when it's positive and it happens also when it's negative, right? So it will go up to t over 2 here and it will go to up minus t over 2 here, okay? And this means that the whole width is going to be 1t, okay? And then it's periodic, so this same thing repeats over and over again. So this signal has a period equal to t. Now, if this is the case, then let's clean up and try to solve for dn. So let's clean up this whole thing so we can work on more clean space, and then we solve for dn after that, the Fourier series coefficients that we need to find for this problem, okay? So find now dn for this signal. So dn in this case, you don't really have many options. You have to use the integration, right? So now dn by definition is equal to, now the period here we call it capital T, the same as we have in the, so 1 over capital T. And then when you say integration over one period, you have to pick your period. I claim that if you pick your period to be from here to here, right? This is the one period that you will decide to do the integration over. It will make your solution a bit easier, right? So now you integrate from minus t over 2 up to t over 2. And what's inside the integral? The x of t. For now, we will write it as x of t. Right? E to the minus j n omega naught. So how do we relate omega naught to the t and the t1 and all these things that we have? Exactly. So your omega naught is 2 pi over that t thing, right? And then there is an n here, don't forget. And then this is a function of time. And you integrate with respect to time. Now we will see that the signal is equal to 1 only from minus t1 to plus t1, right? So this integral needs to be performed only from minus t1 up to t1, because the rest is equal to 0. So this becomes 1 over t, the integration from minus t1 to t1. And then in that case, your x of t becomes 1 multiplied by e to the j n 2 pi over t dt. Okay. Solve this exponential integral. So what's going to be the solution? Everything multiplied by t is going to go and divide by outside, right? So you will have what? 1 over with a minus j n 2 pi over t, right? And this whole thing is multiplied by e to the minus j n 2 pi over t, and upper limit, lower limit.
الديريفاتيف في الكومبلكس زي
Same thing. مفيش أي فرق. Okay. Okay. So this is equal to 1 over t, and then you have minus 1 over j n. خلينا بقى نحط t اللي تحت دي can come up here, right? This t can come up here. And then we have j n 2 pi down there. And then we have e to the minus j n 2 pi over t multiplied by t1. That's when you substitute the upper limit, minus when you substitute the lower limit, e to the minus j becomes a plus, right? E to the j n 2 pi over t t1. كده يا شباب تقدر تشيل دي مع دي وتدخل الماينس ده inside because it's for your benefit. So you have 1 over j 2 وبعدين 1 over n pi. هقول لكم ليه انا كاتبها كده صح. This is this whole thing and then the minus gets inside so it becomes e to the j 2 pi n t1 over t minus e to the minus j 2 pi n t1 sorry لا e to the j squared ليه فين j squared دي no this is 2 multiplied by 2 pi n t1 divided by t. Okay, now this looks to me like, again, if you stop here it's fine, but if you want, if you are asked to simplify this or make it as compact as you can, then this looks to me as I have here e to the j something minus e to the minus j something, and I have 1 over 2j outside. So I can write this as a sine function, right? Sine what? Sine whatever I have here. احنا اتفقنا ان الساين is written how? We agreed that a sine of omega t is equal to 1 over 2j مظبوط e to the j omega t minus e to the minus j omega t, right? So this is what I have here. I have e to the j something and I have e to the minus j something. So this is a sine of this thing. تمام؟ when combined with 1 over 2j. بلاش يا جماعه في وسط ما انا بتكلم دكتور اما اخلص بس ارفع ايدك هسمع على طول اتفضل.
لا بس هناقش الماينس جي
انهي واحده؟ دي ولا دي ولا انهي واحده؟ دي؟
لا لا اي باور ماينس لا اخر شيء
دي؟ ما هي دي. انا نقلتهم مكان بعض عشان خدت الماينس ده كان في ماينس هنا. خدت دخلته جوه فبقى دي اللي بوزيتيف ودي اللي نيجاتيف بس. نقلت دول مكان بعض. اوكي؟ وات ايلس؟ لا انا ما قلتش ال1 اوفر ان، انا قلت ال1 اوفر 2 جي. هقول لكم ليه انا عايزها بره عشان تفورم الساين. مش احنا متفقين ان الساين فيها هي 1 اوفر 2 جي بره، فانا عايزها ال1 اوفر 2 جي دي. اوكي that's why I kept it separate. So now you can write this as a 1 over n pi stays as is, and then this combined with this will give me a sine. Sine of what? Sine of whatever is here, which is 2 pi n t1 over t. بس that's the final form. So the final dn in general can be deduced directly from this expression. Okay? طيب سؤال, when n is equal to 0, what's going to be the value of this coefficient? You will have sine 0 and then divided by 0. لا مين قال؟ But don't forget you are dividing here by 0, right? But this is also sine 0. So 0 by 0 you don't know, right? So what's going to be the value for n equals 0? We don't know. تمام? If we don't know, then okay. You will say okay. Then this is valid only for n not equal to 0. What about for n equals to 0? Go back and apply the law for n equals to 0, right? Because when you go back and apply this for n equals to 0, this part disappears and it becomes only the integration of x of t. صح? That one is solvable. It will give you a number. تمام? So for n equals 0, you need to do a separate part. So for n equals 0, d0 is equal to 1 over the period, integration over 1 period. So from minus t over 2 to t over 2. And this part is no longer there because n equals 0, so this part disappears. And what remains inside is x of t dt, which is the definition of the dc term. صح? We agreed that when n equals 0, this is the dc term. Okay? That's the definition of the dc term, the average of the function. تمام? And then if you substitute, this x of t is equal to 1 only from minus t1 to t1, and it's 0 in the remaining part. So this becomes 1 over t, the integration from minus t1 to t1. What's the value inside the integral? Only 1 dt, right? And then you can solve this. It's going to be what?
2t1.
Exactly, 2t1 divided by t. That's it. So this is d0. So sometimes when you try to put all of them together in one expression, again, this expression, by the way, you can actually evaluate this as n equals to 0. فاكرين الأوبيتال اللي انتوا درستوها when you have 0 by 0, take the derivative of the above part to take the derivative. So if you take the derivative of this, it will become a cosine, right? And if you take the derivative of this, it will become a constant. So now you have cosine over a constant, and the cosine when n is equal to 0 is 1. So it becomes 1 over pi, but still, when those constant, when you took the derivative, you will have 2 pi t1 over t outside. If you do the formula, you will get exactly the same expression that we got here. Things will cancel out and you'll end up with this. So whether you do it this way or that way, in all cases, you need to address the case of n equals 0 separately. Okay? Then in this case, when you try to evaluate it here, it gives you an undefined value. So you have to deal with that separately. Whether you deduce it from this by taking the limit and doing that L'Hopital, or in most of the cases, it's straightforward to go back to the definition and evaluate for n equals 0, because in that case you get rid of the exponential part completely, and the integral becomes very easy to solve. خلاص؟ Yes.
عفوا دكتور كيف الليمتس بتاع الانتجرال تغيرت؟ يعني كانت تي اوفر 2
ما دي عملناها في اللي قبلها، طب انت فوتها في اللي قبلها ليه؟ هقول لك ليه اتغيرت. Because the function itself, as you can see here, is equal to 0 in this range and is equal to 0 in this range. So we only need to integrate this part only. So over that period, there is a part where we have a non-zero value, that's where we need to integrate. And there is another part which is the function is equal to 0, so the integral is not, yeah.
بس لو عوضت التي اوفر 2 يعني حتكون سيم انسر يعني
لا لو عوضت t over 2 ايه هتكون same answer؟ لا.
ما زيرو يعني
بس انت عشان تعوضها ب t over 2 هتضطر تقسم الانتجرال to 3 pieces. And then you say integration over this part, and then integration over this part, plus integration over this part.
Okay.
And the first and the last are zeros, and then you only take the middle one. Okay. Any other questions يا شباب؟ طيب. Okay. Let's look at another. So we did this example already. Okay. And that's the solution. That's the final solution. And but yeah, nice thing here is also plotting the final answer. So this is dn, when n is equal to 0, 2t1 over t, and when n is not equal to 0, you have the sign that we ended up with divided by n, sine n t1 over t2 multiplied by 2 pi divided by n pi. And if you start plotting those, don't forget that dn in general, right, is a coefficient which has a magnitude and a phase, as we agreed before, right? Forget about this part, right? But let's look at this part. If you try to get the plot of this signal, by the way, here it's generally dn is complex, but here dn is real. We don't have any complex values. So plotting f is similar to plotting the magnitude. It's going to give you the same plot, right? Because it doesn't have any phase component because it's already real. And if you try to plot this function sine x over x, it's what's called the sinc function. So it has this nice characteristic, right? At 0, you use this value, and for all the other ones, you use the values derived by substituting n equals 1, 2, 3, 4, 5, and so on, and evaluating this sine over sine n over n. The plot of that has this nice shape, which is called the sinc function. Generally speaking, as a guideline for you, when you are moving from time domain to frequency domain, or vice versa, from frequency domain to time domain, if one of both, so if you start with time domain, and the time domain has the shape of a square, then know that the frequency domain should have the shape of the sinc function, sine x over x. Okay? They call that the sinc function. Okay? And vice versa. So let's assume that the time domain was looking like this, sinc function, sine x over x. Immediately the frequency domain is going to be a square. So it's always this duality. A square in any domain, time domain gives you the frequency sinc, A square in frequency gives you time domain which is sync. And so that's always something, because the square function is very common in many applications, right? So always keep this duality in your mind. Square in one domain will be represented by sine x over x in the other domain. So the other domain is frequency, is going to be sine omega over omega, right? The other domain is n omega, right? So sine n over n, and so on, okay? I'm going to touch on linearity today. We'll do more examples, so let me pick up another example from here. نعم. Example 2, I'm removing it. It's too much because it includes a transition in the middle which gives a delta, and solving this is a bit complicated, so I'm removing that. Example 2 في السلايدز عندكم, I will remove it. كويس انك مصحصح. Okay, so let me.
يعني نشيل example 2.
شيله. I will update the slides, don't worry. So let's look at this nice example from the book. It's not solved in the book, but it's given as a drill. Where is it? There's one solved already, which is also very important to do. Find the Fourier series expansion, Fourier series of the x of t, which, that's a very interesting example, which is a train of impulses. Okay, so actually x of t, I will write the expression because it's written already in the example, looks like this. You have delta, and then after a certain duration, call it to be like the book, call it t naught, you have another delta. So this is delta of t. I'm not gonna write it because it's a shifted delta. So it's another delta, and then at double t naught you have another delta, at minus t naught you have another delta, minus 2t naught another delta, and so on. All of them with the same magnitude, all of them unit delta. So I'm trying to make them the same magnitude, but they might look slightly different. So they all have the same height. They are all delta of unit impulse function. Okay? We call this the train of delta function. So it's delta, 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 repeating in the positive and the negative side. This is periodic, right? And what's the period of this signal?
T naught.
T naught, right? That's the repetition of, after which it repeats itself. So, okay? And if you want to write this as an expression, it's written like this. Summation of delta of t minus k, t naught, and you sum for k equals minus infinity to infinity. Right? This is x of t. Right? So summation of shifted deltas. You put k equals 0, you get this delta. You put k equals 1, you get the next delta. K equals 2, you get the next one. K equals minus 1, you get this one. K minus 2, this one. K minus 3, the next one, and so on. Okay? So this is how you represent this train of delta function as an equation, x of t. Yes?
سوينا انتجريت هنا نلاقي يونستون فانكشن ولا غلط؟
Sorry?
لو سوينا انتجريت الحين نلاقي يونستون فانكشن؟
مش يونت ستيب. هنقول لك ليه؟ لان احنا مش هننتجريت الفانكشن لوحدها، احنا هنضربها في حاجه وبعدين نعمل انتجريشن، صح؟ So to find dn, to find the frequency domain representation or the Fourier series coefficients. يا شباب. Okay? So to find dn, what do you have? The only option is to use the integration. Okay? Again, you cannot really do any comparison of coefficients here because we don't have neither cosines nor exponential functions, right? The complex exponential. So in order to solve this, you have to go to resolve for the integration. The integration says dn is equal to 1 over the period, integration over 1 period, x of t, right? Multiplied by e to the minus j n omega naught t, and you integrate with respect to time. Okay? اتفقنا ان البيريود هنا from where to where? From this start point until the end. Does the end point include another delta ولا without another delta? So if I start my period including one delta, do I include the next delta in the period or not? No, right? Because what repeats is a delta and then void next to it, and then this same thing repeats again with a delta and void, delta and void, and so on. تمام? So my period is gonna look like this. It is from 0 to t naught, but it will look like this. It's including this delta, but it doesn't include the other delta, right? That's my period, t naught. So if I do this integration, 1 over t naught, that's the period. Integration from 0 to t naught. And what's gonna be inside this integral? Only the delta function, right? So delta of t, only the delta at 0, right? Multiplied by e to the minus j n omega naught t dt. Now this is equal to what? انت كنت بتسأل بقى، يبقى انت اللي تجاوب.
E minus j and omega.
So how do you evaluate this integral?
دكتور الانتجرال بتروح مع الدلتا
ايوه
evaluate and
وبعدين
بتفضل الايه
هتاخد الفاليو بتاعت
it's actually as follows, right? When you evaluate the integral of delta multiplied by a function, it's the function at the location of the delta. What's the location of the delta here? Zero. So this is the function when t is equal to 0. What's going to be the function when t is equal to 0? 1. That's it. So the solution for this is 1 over t naught multiplied by 1. This whole integral is equal to 1. تمام؟ لأنه it's simply a delta multiplied by a function. The result of this integration, which includes the delta, because it covers the region where the delta exists, right, is equal to the function at the location of the delta. The location of the delta, t equals 0. So it's equal to this function at t equals 0. When you substitute t0 here, you get what? 1. That's خلاص. مفيش أي حاجة. You don't take anything outside the integral or divide by something or anything. Nothing at all. Okay? Just evaluate that function at the location of the delta. So you get 1 now.
الجراف دوت ده الفريكونسي ولا
Any graph. The time domain. This is the time domain. Here, this is x of t. X of t as a function of t. تمام? This tells me what? d0 is equal to 1 over t naught. d1 is equal to 1 over t naught. d2 1. So regardless of the value of n, it's a constant. 1 over t naught, 1 over t naught, 1 over t at every single value of n, positive and negative, right? So this signal will look in the frequency domain very similar to how it looks in time domain, and that's true. A train of delta in one domain gives you a train of delta in the other domain. But again, here it's not a delta, it's a constant because it's discrete in the frequency domain, right? So it will be here value 1 over t naught, and then 1 over t naught, and then 1 over t naught. But the trick is, what are those locations? احنا في الفريكونسي مفيش حاجه اسمها تي نوت في الفريكونسي.
2 باي على
2 باي over t naught. What's your fundamental frequency? 2 pi over the period. صح؟ يبقى this will happen at 0. احنا هنا بنتكلم n as a function of n. و this will happen at n equals 1 اللي هي at لو قلنا function of omega of frequency, it happens at 2 pi over t naught. And then the next one is 4 pi over t naught. And then the next one 6 pi over t naught and so on. ونفس الحكاية الناحية التانية. Same on the other side. Minus 2 pi over t naught minus اللي هو any coefficient of those is n omega naught. صح؟ n equals 1, n equals 2, n equals 3 and so on. n equals minus 1, minus 2, minus 3 and so on. تمام؟ So this is where the locations of these 1 over t naughts occur in frequency as a function of omega. Alright? Any questions? And again, this dn is already real. So there is no magnitude and phase. It's just one plot. If it was some complex function, to plot it, I had to plot the magnitude by itself and the phase by itself. طب لو طلبت منك ترسمها as a magnitude and phase. تمام? This is the magnitude. What's going to be the phase? 0, 0, 0, 0 everywhere, right? Because it's a real value. Okay, so it doesn't have any phase. It's with zero phase. Okay. طيب. Any questions يا شباب? We reached the end of the lecture. I wanted to give one more example. Can you stay with me for 5 minutes to do one more example? Yes, no?
there is circuits كمان
There is another lecture. خلاص الله معاكم. Done.